Okay, guys, so let's start, guys. So, so let's first say what I did do, what we did so far in this chapter, guys. I explained data transfer instruction, how you copy register to register, how can you copy immediate value to register, how can you copy memory location to memory location. Okay. Also, I explained arithmetic instruction. If you remember, I explained how can you do addition, subtraction, division, multiplication, clear, how can you set some flags, complement, negate, all this instruction. And then in this section, and I think this section is the most important one. In this section, I explained branch and loop instruction, and I explained different kinds of branches, compare and the branches. I explained how can you do some statement similar to the statement you did before in C language, like if else, and so on. Also, I explained how can you do loops, how can you do for loop, how can you do while loop. Okay, I explained it in different ways, so I give you different ways. Okay, but as I said, as an instructor, it's a good idea, especially in programming, it's a good idea to learn different ways, right? And then you can use whatever you want to use, as long as it works to me. In grading, I'm going to consider it correct, as long as it works. You got what I'm saying? So you can use whatever, and sometimes it depends on your programming program. Okay, so I explained different ways. If you remember last time, I explained a very interesting way to do loop, especially when you work on in arrays, very interesting way. And when you work, usually to do loops, for loops you need counter, and also to work on arrays. Also, I need pointer. So I need two things. I need pointer and I need counter. Okay. Last time I explained very interesting idea. I encourage you to use it all the time. Okay. So in what I did last time, I don't need to use counter. So I can use the pointer itself as a pointer and also as a counter. Okay. So in every, you remember what I did last time? In every iteration, I'm going to compare. So if this is, let me write it here. If this is the array, I'm gonna start, X is gonna start from here, and then every iteration, I'm gonna increment X. Once we come to here, okay, and here, for example, in the beginning, load X with, for example, array. So here I have to initialize X with the beginning address, and then every iteration, I'm gonna compare X to array plus, for example, 20 plus number of elements, how many elements we have, okay? So what I'm gonna do here, I'm gonna do for loop, right? So I'm gonna loop, once X to come to here, once I finish the last, in the last iteration, I'm gonna work on this element, okay? Once I finish this one and the increment X, once I come to here, which should be array, plus number of elements. If it is 20, you can put 20. If number of elements are 5, you can put 5. 100, you can put 100. Okay, this is very interesting, but because by doing that, you don't need to use counter. Just you can use pointer. It's very interesting idea anyway. So I explained all of that. I explained what is short and long loops. I explained how can you do comparison signed and unsigned. Okay. So anyway, today I'm going to explain shift and to rotate instructions, new set of instructions, shift and to rotate. And then I'm going to explain Boolean logic instruction if we have time. Okay, so we are very close to finish this chapter. So let's start with shift and to rotate instruction. So what do you mean by shift? Okay. So what I mean by shift is you are going to shift the bits. So you have a byte, as you will see now, okay? So if I have a byte this way, and this byte has here bit 0, bit 1, all the way until bit 7, whatever the value of these bits are, okay? And then, so this is a byte, okay? Then I can do shift operation. So what do you mean by shift? What shift means? Okay, I'm gonna tell you what shift means. Shift means every bit is gonna be shifted to one location. That's the meaning of shift. What do you mean exactly? I mean, after I shift, this bit 7 should come to the position. So bit 7 is gonna come here, okay? So in shift, always I'm gonna shift by 0. So I'm gonna put here 0. So in bit number 7, I'm gonna put 0. Bit number 6, I'm gonna have in bit number 6 here, this is bit number 6 here, I'm gonna have the value of bit number 7, and then here in bit number 5, I'm gonna have bit 6. So all these bits are shifted. So here in bit number 0, I'm gonna get B1, and then this one, so I'm gonna insert 0 here, and then the last one here has to go to the carry. So B0 has to go to the carry. This is the meaning of shift, okay? Why you are doing, this is something else. Just for now, understand what shift means. And later I'm gonna explain how can we use it, or why you are doing that. That's what I'm gonna explain later. Is that clear? So shift means if you have a byte or you have a word, you are gonna insert 0, okay? This way, as you see here, and all the bits are shifted. So every bit is gonna be shifted to next location. Okay, and the last one here is gonna go to the carry. Is that okay? This is what we mean by shift. Is that okay? We have two types of shift. Okay, we have shift left and we have shift right. Okay, this shift what I did here because we are gonna shift in this way. So if you put your hand this way, because you are gonna shift towards your right hand. Okay, so you can see this is my right hand, right? So you are gonna shift it towards my right hand. This is called shift right. Okay. So this is what we call shift right. Okay. We have another shift, guys. If you shift this way, so you insert 0 here, and then you have B0 here, and then B6 here, and then the last bit has to, bit 7 is gonna go to the carry. Okay. This is called shift left, because again, if you put your hand here this way, you can see the bits are shifted here towards your left hand. So we have shift right, and you can shift right, and you can shift left. Okay, guys? You understand what is shift? For sure, I'm going to explain what instruction we have for shift, and more importantly, I'm going to explain. Okay, it looks why I need, if you have a byte, why I need to shift the bits this way. I'm going to explain later why sometimes this is useful. Is that okay? This is the meaning of shift. So I'm going to give you more details for now. Also. I told you this in this section, I'm going to explain shift in details. Also, I'm going to explain another instruction. We call it rotate. And always in case of shift, guys, we shift with 0, as you see here. Always. The bit we insert, I'm going to insert 0 all the time. Okay? Let me ask you a question. If I have a byte and if I shift the byte 8 times, what would I have in the byte? 0, 0, 0, 0. That's true. Because every time I shift, I'm going to insert 0. Every time I shift, I'm going to insert 0. Okay? So after 8 shifts, every shift is going to shift only 1 bit. After 8 shifts, I'm going to get 0, 0, 0, 0. That's true. Is that okay? Again, just now I'm explaining what is shift. Later, I'm going to explain how we can use shift. Okay? Another thing also I'm going to explain, we have what we call rotate instruction. You can tell from the English name. So this is rotate, okay? So what is the difference between rotate and shift? Okay, very close, but I'm going to tell you what is the difference. The difference is that if this is a byte and we have here B0 and we have here bit number 7, when you, for example, also we have rotate right and we have rotate left, same thing. So I have right and left. This is rotate right. Can you see here the arrow? The arrow is pointing at my left, my right hand. So this is rotate right. The difference is that in rotate, here, this bit is gonna go to the carry, and whatever in the carry is gonna come to here. So I'm not gonna insert 0. So after I shift, this is how it looks like, after I rotate, this is how it looks like. Here I'm gonna have B1, and here I'm gonna have carry, and then B7, you got what I'm saying? And then the carry should have B0. Is that okay? So you rotate it. So whatever in the carry is 1 or 0 is gonna come here. It's gonna come here. This one is gonna be shifted. This one is gonna go to the carry. Rotate. Is that okay? Sometimes we call it rotate. And if you understand this one will be perfect, okay? Sometimes rotate, we call it is shift. It is similar to shift. But shift, I'm gonna shift with 0. But rotate is shift. But I'm gonna shift with carry. Agree or disagree? So you shift, but you shift with the value of the carry, whatever is the carry. So yeah, this is true. You can see rotate as a shift, but shift, we shift with 0, rotate, we shift with carry. Is that right? You shift with the value of the carry. So the bit I'm going to insert here, if it is 0 all the time, so it is shift. If it is a carry, okay, so it is rotate. But anyway, you can see rotating. Any questions? Any question, guys? Let me ask you a question. If I have a register A and I rotate register A 9 times, what would I get in register A? If I rotate it 9 times. Yeah, that's right, but raise your voice, yeah. Yeah, I'm gonna get the same thing again, because what I did, B0, in first iteration, number 1, B0 is gonna come here. Number 2, B0 is gonna come to here, right? And then B0 here, B0 here, B0 here. After 9 rotation, B0 is gonna come here, so every bit is gonna return, because I'm gonna rotate it. This is true. Is that okay? Any questions? So same thing, we have rotate right and we have rotate left. So what I did here, guys, this is rotate right. Also, we have rotate left. And rotate left, so it's gonna be this way. So this way, and this one has to go to the carry, and then the carry has to come to here. Is that okay? Rotate left. Oh, any question, guys? Is that clear? What is shift? What is rotate? So what I'm gonna do now, guys, I'm gonna explain. Number 1, what instructions we have. Number 2, I'm going to explain. Okay, but how can we do something like that? Why sometimes you need to rotate? Why sometimes you need to shift? I'm going to tell you why. Okay. Sometimes we need this. Okay. So this is mostly what I explained. I said shift instruction. We have here what we call logic shift, and also we have another shift I'm going to explain right now. It's called arithmetic shift. Okay, guys. For each one of them, we have right and left. You will see. I'm going to give you more details. So for shift, it can be logic or it can be arithmetic. And for each one of them, what is the difference? I'm going to tell you what and why it's called arithmetic. I'm going to explain. Okay. Also, for each one, it can be right or left. Here I explained the concept of shift. Okay. What I explained actually is logic shift. As I said here, guys, logic shift right. Logic shift right. In case of logic shift right, you will shift with 0 this way, as I said, and the last one has to go to the carry, as you see here. Is that okay? What about the old value of the carry is gone? You overwrite it. You understand what I'm saying? So once you shift, P0 is going to store it in the carry. The carry has some value, 0 or 1. Once you store P0, the old value is gone. What I'm saying, we lose it. Okay. Anyway, so the logic shift right, it should work this way. All the time we're going to shift with 0, move this way, okay? Also, logic shift left should be this way, okay? Is that okay? This is for logic shift. How arithmetic shift is different, I'm going to tell you how it is different. So I'm going to explain some instructions that can do logic shift right and logic shift left. Also, I'm going to explain right now what is arithmetic shift left and what is arithmetic shift right. Also, I'm going to explain what instruction we have, and then I'm going to talk about application. Yes, it looks nice, but how can I use them? I'm going to explain. And why is this? You have to be smart. When I use the word arithmetic, it should mean something arithmetic, right? Otherwise, why use the word arithmetic? So there should be something arithmetic here. That's true. That's why we call it arithmetic, right? So I'm going to tell you why this one is called arithmetic, okay? So now, let's explain how, I explained, look here guys, I explain logic shift right. So as you see here, as I said, and logic shift left. Now I want to explain arithmetic shift right and arithmetic shift left, okay? I'm going to explain how it is. So in case of arithmetic shift left, here, if you see here, guys, in case of left, we are gonna insert 0. So we are gonna insert 0, and the last one here is gonna go to the carry. Wow. So this is similar to logic shift left. The answer is yes. So there is no difference between arithmetic shift left and logic shift left. They are the same. For example, here, okay, I'm gonna, so they are exactly the same. In both cases, we shift with 0. The last one is gonna come to here. Okay, this is in case shift left. But shift right is different. Arithmetic shift right is different from arithmetic shift left. From logic shift right. Arithmetic shift right is different from logic shift right. How it is different? I'm going to tell you how it is different. Okay, it is different because if you look here, if you look at this one here, yeah, here, sorry, for the right here. Here, this is logic shift right. I'm gonna shift by 0 all the time, right? But here, in case of arithmetic shift right, I'm not gonna shift with 0. I'm gonna shift with the last bit number 7. So, as you see here. So I'm gonna shift with bit number 7. You got what I'm saying? So the sign bit, I'm gonna shift with the sign bit, right? So if bit number 7 is 0, I'm gonna shift with 0. If the bit number 7 is 1, I'm gonna shift with 1. This is what we call arithmetic shift right. But here, all the time, in case of logic, all the time we're gonna shift with 0 all the time. Is that okay? Why? Why are you doing? I'm getting for sure there is a reason to do that. Okay, guys, any question? So let me summarize what I said. I explained what is shift instruction. I told you we have logic and we have arithmetic shift. For each one of them, we have shift right and shift left for each one of them. Also, I explained in case of left that both of them are the same. So logic shift left or arithmetic shift left, both of them are the same. We're going to shift to 0. They are the same, no difference. But in case of right, logic shift right is different from arithmetic shift right. What is the difference? Small difference. The difference is in case of logic, I'm going to shift with 0. But in case of arithmetic, I'm going to shift with the last bit, with the sign bit number 7. You understand what I mean by we shift with the last bit? I'm going to tell you what I mean just to understand it. Okay, very simple. Here, for example, let me give you some numerical example. So if you have something like that, 1, 0, 0, 1, and then 1, 1, 1. Is that okay? And then let's have another example, 0, 1, 1, 0, 0, 0, 0, 1, for example. Okay, guys? So here, I'm going to shift, I want to shift logic. Here in case, here, I'm going to shift right because the problem is in right. Because in left, they are the same. Both of them are the same. And right. Now, if I shift logic, how it will be done? In logic, we're going to shift to 0. So what's going to happen here, I'm going to have 0, and then 1, 0, 0, and then 1, 1, 1, 1. Okay, so what's going to happen here, and then the carry flag should have 1. So this one is going to go to the carry flag, and then we are going to insert 0. Is that okay? This is in case of it is logic. But if it is arithmetic, it's exactly the same thing, but I'm not going to shift with 0. I'm going to shift with 1. The sign bit here, the sign bit. So it should be 1, 1. Okay, 0, 0, 1, 1, 1, 1, 1. Is that okay? So this is the difference. Here I'm going to shift with 0, here I'm going to shift with 1. Everything else is the same. In this case, you can see here, guys, we have 0 here. In case of logic, all the time we're going to shift with 0. I'm not going to think about it. All the time we think with 0. So it should be here 0, 0, 1, 1, 0. Okay, and then 0, 0, 0, and then the carry is 1. Okay. In case of arithmetic, because this is 0, I'm going to shift with 0. So it's going to be the same, right? Okay, right. Very easy, right? So very easy. So that, in case of shift left, if it is logic or arithmetic, it's the same. We shift with 0. That's it. The only difference when you shift to the right, if it is arithmetic, I'm going to shift with bit number 7. But for logic, always we shift with 0. Yes.
Does it pull from the carry, or do you still add 0? Like, does it work the exact same if you shift it left from logic? Do you still add the 0?
Yes.
Okay.
So Yes. So for logic or arithmetic, for left, logic and arithmetic are the same, exactly same thing. Okay. And there is a reason to make it. So someone can ask me, why you shift with the last bit? Why? I'm going to tell you why. Because arithmetic is doing some arithmetic operations. Okay, so you can every shift you can divide by 2 or you can multiply by 2, right? And if the number is negative, in case of signed division, if the number is negative and I divide it by 2, I have to keep the same sign. I'm going to tell you, give you more details, but there is a reason. Okay, it's not random. So let's see how it works here. Okay, guys. So now, why this one is called arithmetic shift? This one is called arithmetic shift, you guys, simply because when you shift left, you actually multiply by 2. Every shift multiply by 2. Can you give me example to convince me? Yes, I can give you example. This is what this number is. This is number 4. This is number 4, guys. If I shift one time to the right, now it is number 8. If I shift one time to to the left, now it is 16. So you can see now, every time you shift one shift to the left, you actually multiply by 2. This is okay. Same thing. If you go this way, you actually divide by 2. So that's why shift left you multiply by 2, shift right you divide by 2. So if I have 16, and I shift right, so actually it's going to become 8. If you have 8 and you shift right, you get 4. Is that okay, guys? Someone can ask me, so you want to tell us I can use arithmetic shift to multiply by 2 or divide by 2? The answer is yes. Okay, but we already got an instruction before for multiplication. I don't need this one. I can just use multiplication. The answer also is yes. So you can use multiplication. However, some people like this one too much. Why some people like to do when you multiply by 2? Some people like this one too much. Simply because this is very efficient. If you look at the time, if you compare the time needed to multiply by 2 here, if you compare this time with the time needed for multiplication, no comparison. This one is very efficient. Okay. So especially if you do a lot of computation, for example, if you want to do a lot of computation, you want to divide by a big number. So it's a very smart idea to divide by 2, divide by 2, divide by 2, divide by 2. Okay, using shift. It's going to be okay. So that's it. Okay. So if you wanna listen to me, if I have a number, and I think this one will be a question. Let's do it. So this will be a question in the coming lab, not this week, next week. Next week lab is going to be about this shift instructions. So if I have a number here, in register A, and then I ask you to divide this number by 2 using shift, that's easy. So you can just shift right? You can shift right or multiply by 2. So yeah. So if I ask you to multiply by 2, so it's just shift left to multiply by 2. Is that okay? Okay, let me ask you another question because this will be in the coming lab. Okay, so if I ask you, I wanna divide this number by 4, not 2, by 4. What should I do? Yeah, shift twice. That's true. So I shift one time. One time is gonna divide by 2, and then when I shift the number in A, shift it again, okay, to the right. So I'm gonna divide again by 2. Is that okay? That's true. So if I tell you divide it by 8, what should I do? Shift again. That's true. I can shift again. So I can shift one more time. Okay. By this way, you divide by 8. If I tell you I want to divide by 9, what should I do? Just divide by 9? No, using shift instruction. Without division instruction, using shift instruction. Okay. I'm not sure. This will be question in the coming lab. I want to divide by 9. Okay. So the way I can do it, guys, is number 1, I can shift it 3 times. So now I can divide by 8, right? After you shift 3 times. And then I have to see what is the original. For example, let's have some example. So here, let me remember. So, for example, let's have some example here. For example, if you have here 32, right? So if you have 32 and you divide it one time, so it's going to become 16. You divide again, you are going to get 8. Divide again, you are going to get 4, right? Anyway, sorry, I forgot the question now. But the idea, I forgot exactly the question. I'm gonna explain it later. But the idea is that you have to keep the original value somewhere because you are gonna use it later by subtraction, something like that. But sorry for that. But later there is some way to do it. Okay, I'm gonna explain it to you later when I talk about the lab. Okay. So. Okay, so is that okay? You are okay now? Why? So now, here I just, in case of arithmetic shift left, okay, look here, guys. If you shift left here, you actually is gonna, when you shift left, you actually multiply by 2, as I said here. Now this one is 1, now it is 2. Even if it is a minus number, look here, guys. Because, look what I'm gonna, look here what I'm gonna do. Look here, guys. Sorry, where is it? Yeah, here. Okay. Yeah, here. So shift right, you divide by 2. Shift left, you multiply by 2. That's what I said. But if your numbers are unsigned, you have to use logic shift. Okay, to multiply by 2 and divide by 2. I'm going to give you an example now. But if your number are signed, you have to use the arithmetic instruction to divide by 2 and multiply by 2. Okay. So I'm gonna give you one. But what I'm saying now, you can use logic. If you use logic shift, right to left, you are actually doing unsigned. You multiply by 2 or you divide by 2 for unsigned numbers. If they are signed, so you have to use arithmetic number. Okay. That's why here I have to shift to the last bit to keep the same sign. I'm gonna give you details now. Okay. So for now. Okay, so here, guys, what I'm saying now, if you shift left, arithmetic or logic, they are the same. That's what I said. You shift with 0, right? So if this number is 1, I'm gonna get 2. You multiply by 2. If this number is minus 1, look here, minus 1, and I put 0 here, I'm gonna get minus 2. You got what I'm saying? If you shift again, you're gonna get 2 zeros here. It's gonna be minus 4. So it's gonna work. It's gonna work this way if the numbers are positive or negative, so it's gonna work, right? So here in this case. But now, also it should be the same. It should be the same if the number is signed or unsigned. So when you multiply by 2, it doesn't matter if they are signed or unsigned. Always you have to shift to 0. Okay, when you multiply by 2, and then you're gonna get correct result. But in case of division, when you divide by 2, okay. Here, if your number is signed, so I have to keep the sign of this number. For example, if this one is positive 2, this is a positive 2. So here in this time, I'm gonna shift to 0. So I'm gonna get positive 1. So I divide it by 2. So positive 2, I'm gonna get positive 1. But if this one is minus 2, look here, guys, this is minus 2. If I shift to 0, I'm gonna get a completely different. I'm gonna get a positive number. This is a problem. You got what I'm saying? So here, if you shift with 0, if the number is negative, and you shift with 0, you are going to convert the negative number to positive number. You attach it to 0, right? That's why here you have to shift with the last bit, with the sign bit. So here, if you have a negative number like this one, this is minus 2. If you have a negative number like this one, here if you shift with 1, I'm going to get minus 1. Okay? That's why in case of signed numbers, in case of negative numbers, okay, when you divide by 2, you have to shift with the last bit. Okay. So now I'm going to talk about instructions. What instruction we have to do shift? The first instruction we have, guys, you see here, L for logic, S for shift, L for left. So LSL, logic, shift, left. And then here you have to put a memory location, byte. And this memory location has to be a byte. It has to be a byte. By this way, you can shift left a byte logic shift left a byte for a memory location. Is that okay? Similar to what we did before. Second one, we have LSLA. So logic shift left for register A. So here we are going to shift left for register A. We have LSLB. We are going to shift here register B. And these three shift instructions are for bytes. Okay. Okay. So we have only one instruction that can do shift for a word. This one is logic shift left for register D. And it should work this way, guys. It should work this way. So here we are going to shift with 0. So 0 is going to come to here. This bit, the bit here, the first bit here in register, the first bit here in register A is going to come to B here. And then the last one here in B is going to come to C. Because it's a word, this word is like one number. So 0 has to come here, and this one has to come here. Okay? For right, for shift right, we have exactly same instruction, The only difference is I'm gonna replace L with R, because this is left, I'm gonna make it right. So here LSR, logic shift right, logic shift right, logic shift right, logic shift right. So they are exactly the same, but here instead of L, I'm gonna put R, because this is for right. Is that okay? Any question? So this all the instructions. We have 6 instructions as you see, 8 instructions as you see here. 3 instructions for bytes, 1 for word, okay. 4 for right, 4 for left. Is that okay? That's all what we have for logic. Any questions? Okay. For arithmetic, that's what we have for arithmetic. We have same thing like here. 4, but here is going to be 1 less. So we're going to have only, so here we have 8. Here we're going to have 7. You will see now. Look how it is, guys. It's exactly the same thing, but here instead of putting letter L, I'm going to put letter A. Here I put L for logic. Here I put L for logic. Here I'm going to put A for arithmetic. So this one is going to do arithmetic shift left for memory location, okay? Arithmetic shift left for register A, arithmetic shift left for register B, arithmetic shift left for register D. And as I said before, this arithmetic shift left is going to shift with 0, right? And the last one is going to come to here. So this one, as an operator, this one is going to do exactly like the logic shift instruction, okay? But maybe, I don't know, you need to check the table. Maybe this one is going to update more flags compared with the logic. But there is no, what this one is going to do exactly the same thing. This one is going to shift to 0 all the time, right? So this is similar to the logic. Maybe they are different in the flex. You can check. Okay? So now for right, same thing here for right, but the only difference is that we don't have this one. So we have arithmetic shift right for memory, arithmetic shift right for register A, arithmetic shift right for register B, and we don't have arithmetic shift right for register D. We don't have this one. So we have only arithmetic shift right for bytes. Okay, as you see. As I said, arithmetic shift right is different from logic shift right. Logic shift right, we shift with 0 all the time. Here, we shift with bit number 7, it's the same bit. Any questions? Okay, guys. So let me summarize. I think I explained. Yeah. Here, when I use this instruction, guys, I'm gonna do 1 shift operation. So LSLA is gonna do 1 shift operation. What if I want to do 3 shift? What if I want to shift 3 times? So you have to write the instruction 3 times. You got what I'm saying? So you have, because everyone is gonna do shift for 1 bit. What if I want to shift 3 times? You have to write it 3 times, as you see. And then after you do the shift, you can see 3 zeros here. 3 zeros, and then the rest of the bytes. Okay, because these 3 zeros are coming from everyone. This is gonna put 0. Okay. Any questions? And as I said, if I shift 8 times, so this one is gonna be like clear A. You clear A because you are gonna register is gonna be 0. Okay. Any question, guys?
Why is there no arithmetic shift for a register B?
Why is there arithmetic shift for register B?
Or D? Why isn't there one?
Because what if your number is a word and you want to do arithmetic shift for a word? What can I do? So sometimes I want to do operation on a byte. In general, I'm talking in general, not only shift. Sometimes I want to do operation on a byte. Sometimes my number is a word and I want to do operation on a word. You got what I'm saying? So most of the time I'm going to explain how can you do the operation in a byte on a word most of the time, right? So if you wanna shift a byte, you already have A and B and you have memory location, right? If your number is a word, for example, if it is a word in memory, I have to get it from memory, I have to put it in just a D and then I shift it. You got what I'm saying? Even the same thing for addition and subtraction. Because this processor, we call this processor 16-bit processor. What it means, 16-bit, that means the maximum size of operation is going to be 16-bit to 16-bit. The data 16-bit. Maybe other processor may have, they can do operation on a bigger numbers, right? But again, maybe in our application, we may not need more than 16-bit. Okay. Another example, and that's what we're gonna do. Let me explain this one first. So now, guys, I explain what is shift. I explain what is arithmetic shift, arithmetic and logic. I explain what is right and what is left, and how it works. Also here, what I want to explain here is, as I said, here, shift right, you divide by 2, shift left, you multiply by 2. And actually, if your numbers are unsigned, to multiply by 2, I divide by 2, please use the logic shift. But if your numbers are signed, use the arithmetic shift. How? I'm going to tell you how. Look for this example. If you have this number 100 and this numbers again unsigned, if I shift here left, so now it was 1, now it is 2. You multiply by 2, right? Now this number, okay, it is not a negative number because it's unsigned, so it has to be 128. 128, okay? When I shift left here, so I'm going to divide it by 2. Now it is 64. 64, okay? For arithmetic numbers, let's see what arithmetic. In case of sign numbers, you have to use arithmetic. Sorry, I think this one has to be arithmetic shift. You have to use arithmetic shift. Nothing is called arithmetic number in case of sign numbers. Okay. So here, if they again for shift for multiply by 2, still you shift with 0. And for example, if this one is -1, you shift with 0, I'm going to get -2. We shift with 0, I'm going to get -4. You multiply by 2. Is that okay? But here, this is the main point here. Here, so this one is similar to this one. You just shift with 0, but this one is different here. How it is different? So look here, guys. This number here, 1000, because it is unsigned, it should be 128. When I shift with 0, I'm going to get 64. That's good because this is unsigned number, right? But if this number is signed, now this number should be -128. It's the same number, This is unsigned, this is signed. If this one is signed, so this one should be -128. So when I divide by 2, so I have to shift with 1, with the last bit here, okay? Shift with 1. If you shift with 1, you are going to get -64, okay? That's why here in division, in arithmetic shift, you have to shift with the sign so that you can do sign division. Okay. Any questions? Okay, guys. I have another example. So far you explained to us shift, what is shift, and you give us too much details, okay? And then you told us sometimes you use shift. You told us sometimes you use shift to multiply by 2 and to divide by 2. That's what I said. That's it. We're going to use shift just to multiply by 2, divide by 2. That's it. No. Sometimes we use shift for something else, and that's also what we're going to do in this course. For example, I'm going to give you one example here, guys. Look. One of the labs, I'm going to tell you in chapter 3, I'm going to tell you here, I told you we have 80 switches here. That's what I said, 80 switches. These 80 switches are connected to port H. That's what I said last time. Okay, and for sure I'm gonna give you more details in the next chapter. And I told you every switch should have a bit, as I said last time. If this bit is 0, that means the switch is connected. If this bit is 1, that means the switch is disconnected. Right? So every switch should have 1 bit. Okay, and then one of the labs in chapter 3, I'm gonna tell you. You need to get a number from the user. You need to get a number, okay? And I told you to get a number from the user, use this for I'm gonna tell you, use these 4 switches. Okay, so here, and the user should enter the number in binary. Okay, so here the user should use the 4 switches, the last 4 switches here. Every switch is gonna be 1 bit. You get what I'm saying? So that means I can get 0, 0, 0. If you connect to the switches, so 0, 0, 0, 0. Okay, up to 1, 1, 1, 1. Because I'm going to use 4 switches. Every switch is going to give you 1 bit. Okay. So here I'm telling you these 4 bits, the 4 bits here, you should use these 4 bits so that you can get a number from the user from 0 to 15. Okay, and then you have to get this number, you have to multiply it, you have to do some operation on this number. Okay, okay. What is the problem? The problem is that when you read port H, you cannot only read 4 bits. Okay, I have to read a byte. So actually what we have now, I have a byte. This is port H. My number is here. My number is here. This is the number. Okay, this is the number. This is my number. My number is here. And I don't care about whatever here. So I don't care about this one. Okay, so in this case, so how can you get a number? So my number is here. How can you get a number so that I can multiply, I can divide, I can compare, I can do whatever you want to do. So the way you are going to do it, you have to shift this one 4 times. Because if you shift this one 4 times, the number the user enter are going to be here, and then 0, 0, 0, 0. Okay, and then now I have a number between 0 and 15. You got it or not? You got what I'm saying? So the problem is that when you read it, you are going to have a byte. But actually my number is 0, right? So I don't care about this one. So I'm going to shift it 4 times. Once I shift 4 times, I have shift the 4 bits, which represent my number, but my number now in a byte. And there is 0, 0, 0. So now this byte can have a value between 0 and 15. Then I can use this byte, I can compare. If it is 0, I have to do something, or I can do whatever I want to do. Now I have a byte. This byte should equal to the number entered by the user. Okay, guys. So anyway, this is also another way to use shift instruction. Any question? Is that clear? We will do that in chapter 3. Any questions? Okay. Now let me see if I missed something here in the slides before. Yeah, so here I explain what is arithmetic. I explain this one. Here, this table is gonna summarize all the instruction we have. I explained all of them. Also here I explain how shift works. So every bit is gonna be shifted. So 0 is gonna come to here. This bit is gonna come to here. The last bit here has to go to the carry. So here, and in the quiz, you are gonna have a question like this one in the quiz. I just wanna make sure you understand how the instruction works. So I'm gonna tell you, for example, register A stores the number 95. So for example, 95 like this one in register A, okay? And the carry equal to 1. And then I'm gonna ask you, okay, so what is the value? So here, for example, I can give you this one, and then I'm gonna ask you to give me this one. I'm gonna tell you after I use arithmetic shift left, what is the value of A and what is the value of carry? It's very easy, right? So you have to put this one here, and then you have to do the shift, and then see what is the value of A, what is the value of the carry after you do the shift. I just want to make sure you understand, okay? Same thing here. Here, same thing, but for a memory location. So I give you, this memory location should have this value, and the carry is equal to 0. After you shift using arithmetic, I just want to make sure you understand how this one works. So here, because this one is shift right arithmetic, here we are not going to shift with 0. We're going to shift with the last bit. So as you see here, this last bit, I'm going to double it. Okay. So this bit, I'm going to shift with 1, as you see here. Okay. So I'm going to give you this. I'm going to give you this value. I'm going to ask you to shift, and then show me what is this value. Same thing here, guys. Nothing is new, but same thing for shift and also for rotate. I'm going to explain what is rotate now. This also for rotate, okay. Is that okay? So next, this will be in the quiz. Just, I want to make sure you understand the question. So, sorry, you understand the instructions. So I'm going to give you A and C, and then I ask you to rotate, and then tell me what is the value of A after you rotate. Okay, what is the value of the carry, and so on. Okay, now let's explain rotate. Again, as I told you, rotate is not something new. It is shift. But this time, I'm not going to shift with 1. I'm not going to shift with 0. I'm not going to shift with the sign bit. I'm going to shift with the carry. That's what I said about. And we don't have arithmetic rotate and logic rotate. We don't have. We have only rotate. Okay. So, for example, here, guys, like here in this example, here rotate left. So here is the bits. The bits have to go to left here this way. It's gonna go this way. So the carry has to come to here, and then bit 7 has to go to the carry, right? So as you see here. So rotate means shift with carry, okay? With the value of the carry. I told you here after you rotate 9 times, I'm gonna get the same value for A again. This is for rotate left. We have rotate right. As you see here, rotate right. So everything, when you rotate right, this bit here has to go to the carry, and the carry has to come to here, okay? Any question? So what instruction do you have here? I'm gonna tell you what instruction we have. We have ROL, rotate. RO means rotate, L left, rotate left for a memory location. And this memory location has to be a byte. And then we have rotate A, and then we have rotate B. Is that okay? We have here, this is for right. Same thing, we have exactly same instruction here, but here I'm gonna use R for, here I used L for left. Here I'm gonna use R for right, okay? So here I'm using L for left. Here I'm going to use R for right, okay? We don't have rotate instruction for words. So we don't have rotate, but that doesn't mean we cannot do it. Still you can do it, but you cannot do it using one instruction, but you can write multiple instructions to make a rotate for words. Is that okay, guys? Any question? Again, this is byte. This memory is a byte. Don't be confused. This is a byte. Always, most of the cases, this one is a byte, okay? Any question? Okay, let's have some examples here. Before I am done with this section, it's a very easy section. But let's have one example. Also, this example can tell you. It can tell. Also, this example is very. It's just one example. This example you can learn from this example how sometimes how shift is useful. Sometimes shift is useful. Okay. I give you several examples. I explained about arithmetic, divide by 2, multiply by 2. Also, I explained about the switches. If you have a byte and you just want to take some bits from this byte and you want to create a number, you want to create a byte with these bits, as I explained. Okay. I have another idea here. How can we use shift and rotate instruction? So the idea is, look here, guys. If you have a word, byte or a word, it doesn't matter. If you have a word, and this word you have 0, 1, 0, 1, 1, 1, 1, some numbers here. Is that okay, guys? Let's see. So I want to count for some reason. I want to count how many ones we have here, or how many zeros. For example, let's now. I want to count how many ones we have. So you have 16-bit, 0, 1, 0, 1, 0, 1. Okay. I want to count how many ones we have here. How many ones? Okay. So someone can ask me, or why you need to count the number of ones? Why? Okay, why? Give me application. Okay, maybe. Okay, this can be useful in many applications, by the way. So, for example, maybe this voting. For example, maybe you have like a voting system, and everyone here is connected to a switch. For example, connected to a switch, and I wanna know. How many? So everybody has to vote, yes or no, approve or disapprove, right? So you have a switch. So you are gonna connect on this switch. You gonna understand? That's why I need to count the number of ones. So I need to know how many people. So these ones and zeros are coming from switches. So 1 means approve, 0 means disapprove. So I want to know how many people approved. So I need to count how many ones I have. Is that okay? You understand what I'm saying? You can think in many applications. Maybe this one's coming from sensors. Maybe you have a number of sensor. For example, you're gonna put different sensor, and this sensor should sense something like fire, for example. And you wanna know how many. If for sure, if you have one sensor give you alarm. I'm just giving you some random application, but you can think about other applications. Okay. So maybe this one coming from somewhere, okay? And if only one sensor tell you there is alarm, maybe you have some doubt. Okay, but if you, for example, if you have 4 or 5 sensors, all of them confirm something happened, okay? So that means you have a stronger belief that something is wrong. You get what I'm saying? Something like that. But anyway, so now the question is that if you have a word like this one, okay, guys, it has some ones or zeros. How can I count the number of ones here? I want to count the number of ones. What should I do? Any idea? I'm going to tell you the idea. The idea is when I shift, right or left, when I shift, one bit is going to go to the carry. And then I taught instruction before, how can you check if the carry is 1 or 0? You got what I'm saying? So this is the word here. When I shift, this guy is going to go to the carry. Now I'm going to ask the carry, are you 1 or 0? If the carry tell me I'm 1, I have a counter. I'm going to increment the counter. Because you can check the carry. I taught an instruction before to check the carry. Now I'm done with this guy. When I shift again, next time, I'm going to get this guy, right? So every time I shift, I'm going to get 1 bit. When I shift, actually, I'm going to get 1 bit, I'm going to put in the carry, and then I can check the carry. Is that clear? Any question? So this bit, in the first shift, this bit is going to come here. Shift number 2, this bit here. Next shift bit. So every shift, I'm going to get 1 number. Okay, put it in the carry, and then I can check the carry. Okay. Is that clear or not? You got what I'm saying? So I think I have a nice figure here. I can choose a figure before I choose a program. Yeah, here. Look here, guys. So here, because we need to count how many zeros or ones. Here, I give you example about ones, but here I want to count 0. Doesn't matter. It's the same thing, but here I want to count how many zeros we have. Okay. So I'm gonna shift every time you shift, as you see here, guys. So this bit in the first shift, this bit is gonna come here, and then I'm gonna check the carry. Next time, this bit, which is the second bit here, is gonna come to here, and then this bit. So every time I shift, I'm gonna get 1 bit until iteration number 16. So I have to shift 16 times because this is a wall. I need to shift 16 times. Is that okay? So how can we solve the problem? This is the way you should think about it. Number 1, I need to shift 16 times. So I need to make for loop. 16 iterations. This number 1. Okay, guys, I need to make for loop for 16 iterations. This number. Number 2, in each iteration, I have to shift. It checks the bit. It checks the carry bit. If the carry is 1, for example, it depends. If I want to count how many zeros, if the count is 0, I'm going to increment the counter. That's exactly what I'm going to do. So I'm going to show you now. This is the program here. But this is a logic. Guys, I know some of you don't like programming or think programming is difficult. Believe me, I don't think programming is difficult if you think this way. You need to have like a pseudo code or something logic like this one. If you have a problem, what do you need? Number 1, I need for loop, right? 16 times. Number 2, in every iteration, what should I do in every iteration? I have to shift register D, and then I have to check if the carry is equal to 1. If the carry equal to 1, do nothing. Do nothing. Just shift again. Go to the for loop. Okay. If the carry equal to 0, increment the counter. Okay. This is the logic here. Okay. And then once you have this logic, you can. I already taught how can you make for loop. I already taught how can you shift. I already taught before how can you check the carry bit, and that's what I'm gonna do now. First, I need for loop for 16 times. Show me where is the for loop. I'm gonna show you where is. Forget everything. This is the for loop. So only look at the for loop. How I created the for loop. Okay. So this is the body. This is the body of for loop. Forget this body for now. And this is we loop here. This is a loop, and this is, as I explained before many times, here I'm gonna use a counter, memory location counter here. Okay. So here every iteration I'm gonna decrement the counter. If it is not 0, go back. By this way, I'm gonna loop here. I'm gonna repeat this part. Yeah, this part. I'm gonna repeat this part 16 times. Is that clear? Just look at the for loop. Okay. So every time I'm gonna decrement the counter, go back. So I'm gonna loop here 16 times. This number. By the way, this is how I grade the tests, and this is how I grade the final. How I grade the final, I tell myself, to solve this problem, the student has to make for loop, okay? And then it has to shift, it has to do 1, 2, 3, 4, okay? And then I see if you did for loop correctly, I give you the full mark for the full loop. You got what I'm saying? So that's the best way. So if you have a programming problem, try to divide it into pieces. That's what I do, right? So you need to shift. So now this is a problem. What should I do in each iteration? In each iteration, number one, I have to shift. As you see, number one, I have to shift. After I shift, so now I got 1 bit. I put 1 bit in the carry. So now I'm going to ask the carry. How you ask the carry? Can you ask the carry? Yes. I explained a couple of instructions before, if you remember. Branch if the carry is 1. Branch if the carry is 1. So if the carry is 1, I'm going to skip this one here. See how I made it, guys? So here is this shift. This shift is going to take 1 bit and put it in the carry. It's going to take 1 bit and put it in the carry. Is that okay? And then here, I'm going to ask the carry, please carry. If you are 1, skip this one because I don't want to increment. Does that make sense? So every time I shift so that I can get 1 bit in the carry. Then here I ask the carry. Branch if carry is set from skip equal to this one. So the only way to count here is the carry equal to 0 because I'm counting how many zeros we have. Any question? Now, what if I want to count the number of ones instead of number of zeros? Very interesting. I'm going to change only 1 letter. So here in this program, if I want to count the number of ones instead of number of zeros, only one letter. Look here, guys. Look at this letter. If I make this one C instead of S, this one, if I make it C, so I'm gonna count the number of ones. Why? Because you are gonna skip the counter. You are gonna skip the counter if it is 0. 0 you are gonna skip. 1 you are gonna come to here. Any question? Again, this one, B means branch, C if the carry is set. And we have BCC, branch if the carry is clear. Any question? Raise your hand if you have any question. Any question? Okay. Before I still have another example here. I want to teach this example before I go to next section, which is about Boolean logic instructions. Okay. I'm done with shift and rotate instruction except this one. Okay. So what I want to do here, guys, in this example is you remember add with carry. I need someone to tell me why we have add and why we have add with carry. What was the logic? What was the purpose to having add with carry? Tell me. Yeah, you know.
Let's say you do another operation and you want to pull that number in from the operation. So you could just see what's in that and add to it.
So what you want to say is, if you want to add byte plus byte, we already have an instruction to do that, right? If you want to add word plus word, we already have an instruction to do that, right? Okay, now what you have a bigger number, like 32 bits plus 32 bits. We don't have an instruction to do that, right? So that's why we have add with carry, so that when you add, okay, you can use the carry, you can add the carry with the next operation, right? That's why they invented it. Okay, same thing I'm gonna teach now. Okay, if you wanna do shift right, you have an instruction to do shift right for a byte. You have an instruction to do shift right for a word. Okay, what if you want to do shift right for 32 bit, a bigger number? Again, I'm telling you, this is a programming language. You can do anything, even if you don't have the instruction. Okay, but what I'm saying, I cannot do it using one instruction, but still I can do it using multiple instructions. That's what I'm teaching now. Okay, so what I'm teaching now, what if you have a big number? Whatever it is, the big number can be 32 bits. Okay, 32 bits. Yes, it can be 4 bytes. It can be 1 million bytes, whatever, it doesn't matter. So I have a very big number. Okay, I have a very big number. Okay, 1 billion bytes. Okay, just a different, any number. So any number of bytes. Okay, it's just a big number. Okay, and I want to shift this number. For sure, I cannot do it using one instruction, but still I can do it. How? So I want to shift it. Okay, so actually, what I want to do, the first byte here, I have to put 0 here, right? And this one here has to come to here, and this one here has to come to here. And so I have to continue this way. The first bit in this one has to come here. I have to shift with this bit, right? Here, this bit I have to shift with this bit, and then the first bit here has to go to the bit. That's what I have to do, right? But how? How? Because this is what shift is. What shift is, I have to shift to 0, and every bit should be shifted by 1. And the last bit has to go to the right. This is the mean group shift, right? So how can you do it? Okay, I'm gonna tell you how I can do it. Number 1, the way I can do it is, look here, guys. I can take this byte, I can make shift right for this one, okay? When I do shift right, so the 0 is gonna come to here. Yeah, that's what I wanna do. And the last bit here is gonna go to the carry, right? So this is logic shift right. Is that okay? But starting from the second one, I'm gonna shift to carry. Because this bit is gonna come to the carry. And then I'm gonna shift with the carry. So this bit is gonna come to here. And that's exactly what I wanna do. I need this bit to come to here, right? But the way I did it, this bit has to go to the carry first, and the next instruction is gonna come to here. That's exactly what I did. So here, what I did, I'm gonna use logic shift right. So the 0 is gonna come to here, 0 is gonna come to here. That's exactly what I wanna do. And then this bit is gonna go to the carry. And next one, I'm gonna say shift with carry. Do you have something called shift with carry? Yes, rotate. Rotate, shift with carry. That's why here, I'm gonna say rotate right. So here, what I'm gonna say here, so this one is gonna come here, this one is gonna go to the carry, and then I'm gonna say rotate right. When I say rotate right, I'm gonna shift with the carry, because this carry has to split, so this is gonna come to here. This is exactly what I want to split here, right? So the way I have to do it, the first bit here is gonna be shift, normal shift. But all the other bits are gonna be rotate. So the first one here should be shift. And then shift, for example, if you go right, shift right. And then everything else should be rotate, 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 rotate. Okay? Why I have to rotate? Rotate because rotate is shift with carry. Because the output of this one has to go to carry, and then I have to insert here with carry. Is that okay? So this is the way I did it, guys. You can see here, you have a memory location. So we have 4 bytes here. I assume we have 4 bytes. 0, x, 1, x, 2, x, 3, x. This is 4 bytes, byte. This byte is going to be shift, as I said, shift for this one, and then rotate, rotate, rotate. Is that okay? The first one, shift, and then rotate, rotate, rotate. Is that okay? Any question? So this 4 instruction here are one shift operation. Okay, so it's going to be 32-bit for a 32-bit number, one shift. Okay, so if you want to shift it twice, we have to repeat it 2 times. Because this 4 instruction are going to do one shift if you have 32-bit number. One of the coming lab, not this lab, next week. The coming lab, it's very interesting. You are going to have 8 programs, but short programs. And interesting, I like them, okay? Very interesting programs. For example, they have some little tricks, but I give you some hint to solve it, but you will like it. So for example, the instruction we have right now, you can shift with 0, or you can shift with carry, right? That's what we have, right? In the coming lab, I'm going to tell you shift with 1. What would you do? You get what I'm saying? You got my boy? So here in the coming lab, I have one question. I'm gonna tell you shift with 1. We don't have this instruction, right? All what we have, I can shift with 0 or I can shift with carry. What should I do?
Carry 1.
Yes. Who said this? Thanks. True. So all what I can do is I can set the carry. I already taught one instruction to clear the carry and set the carry. I can set the carry and change shift with carry. Set the carry, shift with carry. Set the carry, shift with the carry. Is that okay? That's what we're going to do in the comment. Any questions? I'm done with shift and rotate instruction. Now I want to move to the next instructions. Any questions? Now I'm going to teach Boolean logic instruction. Okay. They are very important, very interesting. Okay. So what you mean by Boolean? Okay, I'm going to tell you what I mean by Boolean. Logic operations. Okay. So now what I want to teach is how can you Boolean logic operation. What Boolean logic? First, Boolean logic here means this is logic operation. That means we are going to do bitwise, bit by bit. we're gonna do bit by bit logic operation. So if I have a register A and you have a register B or a number or memory location, so what we are gonna do now, bit by bit logic operation, bit by bit logic operation. Is that okay? So what logic operation do we have here? We have AND, we have OR, we have XOR. This is the only the three operation we have. Okay, so what I'm gonna teach now, guys, if you have a byte and you have a byte, how can you do bit by bit AND operation? How can you do bit by bit OR? How can you do bit by bit XOR? Okay, very useful, very important. I'm gonna tell you why. Application. So I'm gonna teach number one, I'm teaching instruction, and then I'm gonna teach how can you use them. They are very useful. I'm gonna tell you why. Any question? Okay, but before I proceed, let's just make a very quick review on what is AND. The truth table of AND. What is AND? I like to teach AND this way. Maybe you learn it in a different way, but I like to teach this way. This is AND works. This is how AND works. Look here, guys. If one input is 0, the output is 0, regardless of the other input. This is the first rule. Second rule, if one input is 1, the output should equal to the other input. This is the truth table of AND. So AND, this is how AND works. Number one, if one input is 0, don't look at the output is 0, regardless of the other input. Is that okay? That's why I'm saying here, if this is 0 and this is X, X means whatever, 0 or 1. So if one input is 0, the output is 0, regardless of the other input. Is that okay? The other case, if one input is 1 and the other one is X, again, X can be 0 or 1. So the output will be similar to this one. Is that okay? You agree? This is how AND works. This is how AND works. Is that okay? Okay. But how? Yeah, this is how AND works, right? Do you agree? This is how AND works. Okay. But how this can be useful? I'm going to tell you, very useful. I'm going to tell you how. Very interesting. I'm going to tell you how it is useful. It is useful because, look here, guys. Look, this is a microcontroller, guys. This is a microcontroller. And then, for example, here I'm gonna talk about the LEDs here, the LEDs. Every pin, we have here pin, we have port B. Okay, again, I'm gonna explain in chapter 3 in details what are these. Okay, so we have port B. I connected the LEDs to port B. Okay, so here, every port should have a pin like this one. So here I connected the LED this way, and this is the LED. Is that okay? And then internally, we have a byte here. So we have here 8. We have 8 bits. Everyone is connected to one LED. That's why we have here 8 LEDs. Is that okay? Internally, we have 1 byte. 1 byte here. Is that okay? Internally, there is a connection here. There is a circuit that connects here. Okay? So if I put here 0 logic in this bit, so every bit is connected to 1 pin. Very interesting. Every bit, so there is some byte internally. Okay? Every bit is connected somehow to 1 pin. Okay? So if I put 0 logic in this bit, you actually gonna put 0 volt here. If you put logic 1, you're gonna put 5 volt. This is how it is. Okay? So here, if I put 1, so actually I'm gonna put here 5 volt. At any time. So this is dynamical. So anytime you put 0, so this pin is gonna be 0 volt. Okay? This is logic, there is volt here. Okay? So every pin is connected to here. Is that okay? That means if I want to turn this LED on, I have to put here 5 volt. And in order to put 5 volt here, I have to put 1 here. That's very easy, right? So at the end, the problem became I have a byte. Every bit here in the byte is connected to 1 pin. And this pin is connected to LED. So if you want to turn the LED on, please put here logic 1. If you want to turn it off, please put here logic 0. That's it. You got it? You got it? So now, you got what I'm saying that? So now, how can I do that? You are telling me, okay, let me summarize this. I have a byte, right? every bit is connected to one LED. Yes. And if you want to turn this LED on, you have to put 1. If you want to turn, you have to put 0 in a certain bit in a byte. In a certain bit in a byte. How we do that? Most of the instruction we had can work on a byte. Not, they don't work on a bits inside byte. You got what I'm saying? So now this is what I'm saying. If you have a byte, and I have 1 bit. I wanna set this bit. So that to turn the LED on, the LED connected to this bit on. Or sometimes I wanna clear this bit to turn the LED off. Sometimes I want to flip this bit. Flip means if it is 0, it can become 1. If it is 1, become 0. Like that's exactly what we're going to do if in chapter 3 when you do flashing. If I want to do flashing LED, what I'm going to do, this bit, every 1 second, I'm going to flip the bit. By this way, you can do flashing. So 1 second, flip the bit. Wait 1 second, flip the bit. Wait 1 second, flip the bit. Is that okay? So what I'm going to do, so we need to learn. If you have a byte, how can you set some bits inside this byte and don't change the other bits? So I want to only manipulate 1 bit and don't change the other bits. How can you set? How can you clear? How can you flip? And don't change the other bits. Please, don't change the other bits. Right? Again, keep in mind, it's not easy as it looks. Why it's not easy, guys? Because the operation we have work on a byte. I never taught, for example, when I copy, I explain how you can copy byte to a byte, right? But there is no instruction to copy bit inside a byte to bit inside a byte. We don't have this instruction, but we don't have an instruction to do that, but you have to write a code to do it. Is that clear? So here the question is that, maybe 1 or more bit. How can you set some bit? How can you clear some bit? How can you flip the bit? And this is one thing. The second thing, don't change the other bits. Don't change. And you have to do operation on the whole byte. So I have to do operation on the whole byte. After I do this operation, I have to manipulate, I have to change some bits, and I shouldn't change the other bits. Is that okay? How can you do that? I'm gonna tell you how. Let's ask end. Let's look at the end again. What end? Look how end works. And then see how end can help us. Look here, guys. This is how end works. If you have 0 and x, you are going to have 0 regardless. Okay? If you have 1 or x, I'm going to have x. So 1 means no change. If you have x, I'm going to get x. 0 means, if you put 0, that means I want to clear some bits. That means we are going to use AND, logic AND, if you want to clear some bits. How? I'm going to tell you how. For example, this is the byte we have. I want to turn so I want to put here 0 and then no change here. So no change. They have to have the same value. I want to clear this bit. And I don't want to change the other bits. And the operation has to be done on a byte. Is that okay? So how can we do that? Number 1, you have to AND this number 1. Again, very, very easy, very clear. If you want to clear some bits, you have to use AND. AND is used if you want to clear some bits. Is that okay? So now I want to clear a bit or more than a bit. For now, let's assume I want to clear 1 bit. So the way I can do it, guys, I'm gonna do, for example, this is register A. So I'm gonna do 0 here because I want to clear this one, and then I'm gonna put 1, 1, 1. 1, 1, 1, 1. Okay. So the result should be 0, and then it should be bit number 1, whatever here in bit number 1, bit number 2, bit number 3, all the way until bit number 7. And this one has to be stored in register A. So register A should equal register A and some number here, what we call mask. And I have to select this number here, so that the bits I want to clear, I have to put 0, because that's what N is known. If you put 0, I'm going to get 0. Yes, if I put 0, so I'm going to get 0 here, right? If you put 1, I'm going to get the same thing here. Okay. So very simple. You have a byte. I want a 0. I want to 0 some bits, and I don't want to change other bits. The bits you don't want to change, put 1 in this location. The bits you want to change, you change to 0. Is that clear, guys? The idea is clear? Any question? I'm gonna teach how can you do and now I'm gonna teach. We have an instruction for and. I'm gonna teach it, but now I'm teaching how it is useful. How can you use it? Is that okay? Is that okay with and? Let's look at the second one. Or, how or works, and also using the same what I taught right now to try to think how can we use it. But let's first how it works. Or work is this way. Or if one input is 1, so regardless of what I have here, I'm gonna get 1. That's how it is all. If I have 0, okay, so here I'm gonna get x. If I have 0, I'm gonna get the same value here. So if this one is 1, I'm gonna get 1. If it is 0, I'm gonna get 0. Same value here. So if I wanna set some bits, yeah, this one can help me to set some bits. And this one, no change. If I don't want to change some bits, I can put 0 because 0 is gonna be no change. Is that okay? That's exactly how it is. So if you have a byte, and then I wanna set this bit, I have to put 1 here, and then I don't want to change the other bit, so I have to put 0s. And then I have to use OR operation. If I do that, for sure I'm gonna get 1 here, and then I'm no change here. So whatever here is gonna come here. Is that easy, right? So conclusion. Again, we need half a byte. I need to manipulate some bits in a byte, and I don't want to change the other bits. Okay. What do you mean by manipulate? I mean by manipulate 3 things: set, clear, and flip. Okay. I explained. If you want to clear, you have to do logic AND. If you want to set, you have to use logic OR. Okay. How? I explained here. The bits you want to set, you put 1. So this is a byte. I'm going to do OR, and then the results is stored here in this location, in this one. Is that clear, guys? The last one, XOR. Let's see how it works, and I need someone to help me tell me how it is useful. I'm going to, but let me first tell you how it works, XOR. This is how XOR works. If you put here 0, X, you are going to get the same X. This is how XOR, how it works. If you don't believe me, go back I think you already learned it from digital system. You see how it works. It should work this one, okay? And then if I put here 1, and this one is X, so I'm gonna get X prime here. This is the truth table of XOR. Okay? So 0 XOR any number, I'm gonna get the same number. So 0 is gonna make no change. 0. 1 is gonna make flip. So X prime here means if I have 1 here, I'm gonna get 0. I have 0, I'm gonna get 1. Is that okay? So from what I wrote here, you can see 0. So here, this one, no change. Here, flip. Perfect. So if you want to flip some bits, if I don't want to change some bits, I use this one. Okay. So now, if I have a byte and I want to flip this one, flip. I'm gonna put 1. I don't want to change the other ones. I'm gonna put 0s. So what I'm gonna get here, I'm gonna get B0 prime. Here we have B0. I'm gonna get B0 prime, and then these ones are gonna come here, no change. Again, you can use the same logic to manipulate more than 1 bit. For example, the same thing, right? So I can put 1 1 1 0 0 0 0. So these ones are gonna flip. I'm gonna flip these bits and no change to this bit. Pretty easy, right? So the bits you don't want to change, put 0. The bits you want to change, you want to flip, put 1. Right? This is how it works. But OR is different, right? Or if you don't want to change, you put 0. If you want to set, you have to put 1. And if you want to clear, you have to put 0. If you don't want to change, you put 1. Conclusion is that I'm gonna teach 3 logic operations, and or XOR. Is that okay? How it is useful? They are very useful because and is used if you want to set some bits. OR is used if you want to and is used if you want to clear some bits. Or is used if you want to set some bits. XOR is used if you want to flip some bits. So you have a byte, I want to just manipulate some bits, and I don't want to change the other bits. Okay? We don't have an instruction. All the instruction we have, usually you have to work on byte with byte. We don't have an instruction to work on a bit inside the byte, so byte to byte. Okay? Still 49. So how logic operation are used? That's what I said. It can be used for bit manipulation. Bit manipulation set clear flip. And this is useful if you have one external pin and you wanna this pin you wanna for example LED, you wanna put here 0 volt or 5 volt, 0 volt or 5 volt. Also how it is used also here. Also it can be used if you wanna check some bits if they are 0 or 1s. Like branch, okay, I think I explained this one before, and I promised, I told you what I explained before. I explained branch if clear, branch if set, and I told you they are short, and later I'm gonna explain long branch. Yeah, that's what I'm doing now. So how can you, what's the time? 50. Okay, next time I'm gonna.